Hello, everyone. So can you see this?
Yes.
Yep. So compared to San Tutor, we are much earlier on. The lab has only existed for a little over a year, but our problem is the same as everyone. Healthcare systems cannot live by importation alone. And that is our problem in the Philippines. So we want to tell you a little bit about the Integrated Protein R&D Center, the IPRDC here in the Philippines. This is a reminder for you who don't know where you are. This is where we are, little north of Australia, south of China. Our primary job, like so many other people over the last year, is to build COVID tests. And so with much help from NEB and Scott Sherrill Mix at Penn, we've built a couple of LAMP and PCR tests using commercial enzymes. And it became very clear that we couldn't afford to make the tests we need to for the people we need to serve in an LMIC, still with commercial. And so we started on the side a small project to make our own enzymes. And we didn't get much support from the government until, like many things in the Philippines, politics intervenes. And the head of the Philippine Red Cross, Richard Gordon, asked why the DOST, that's the government, the science technology government, weren't making our own reagents. Why is the Philippines importing everything? And so, of course, that was a green light for us to go back to the government. So over the last 8 or 9 months or so, we have been trying to work out what we should build, largely taking lessons from yourselves. And that turned into the IPRDC. Bayern, the group that we have here at Ateneo, the fledgling group we've just started, is a combination of biologists, that's my expertise primarily, chemists and bioengineers. And so maybe what's different is that we purposefully think that biology won't solve the problem, chemistry can't solve it, and engineering won't solve it. It's a combination of all three. Obviously to make proteins, and then we have to try to make proteins and diagnostics in the Philippines. So what Jenny was saying, all the problems and trials and tribulations, that's exactly the stage that we're at now for the diagnostic tests we're making, let alone the ones to be made using the proteins we make. So the biology project is very, standard conventional gene expression protein biochemistry at small scale. Then we've got a group who are making resins, so to try and reduce the cost by actually making our own resins rather than buying them from GE or so Cytiva. We are going to buy an actor, but then we want to be able to make cheaper actors. So we've got an engineer who's already made an HPLC. They're going to make some FPLCs for us. And then we're going to build bioreactors. We have some again, we'll buy commercially, and then we'll make our own. And then we have robotics to do the dispensing. So the point of the IPRDC is that the interesting part maybe, or the slightly different part, is the I part, the integrated. So it's integrated biology, chemistry, bioengineering. So this is as how it would flow together. The core gene expression is project 1, small scale. And then the other projects either build the resins, the reactors, the FPLCs, so that we can do it at scale and keep the costs down, because there's no way we can afford to do the production at the scale we want by using everything that's commercial, both the chemistry ware and the engineering hardware. We have a small proof of principle. This is only a day job, but we've got a couple of students who made some HIV-RT, which seems to work reasonably well, both in RT-PCR and RT-LAMP. So that was encouraging. We've made some progress with RNase inhibitor, which is also rather expensive for us to import. And we have a slew of BL21s and DH5s that we've got at least the cloning stage, and you'll recognize many of these, I'm sure. So now we have the funding from the government to start the IPIDC, maybe back end of this year or January the 1st, depending on funding, we can really get going, and we're very much looking to learn from yourselves. So the IPIDC is very much seen as not just for academia, not just for industry, but for also high schools and some universities. So this is the first phase, to build diagnostic enzymes like we all are doing, trying to build a pyramid so that each layer makes the layer above it more cost effective. And then obviously there is a life beyond diagnostics, there is a life beyond COVID, but that will be in subsequent years. So this is our immediate business plan. So once the IPIDC makes proteins that are commercializable, then it gets spun off into Biologics, a spin-off company from Ateneo, and then they will sell directly to customers. And this discussion down here around scale-up is really, very germane to what Jenny was discussing. So this is the IPIDC. It's integrated biology, chemistry, bioengineering, to initially make diagnostic proteins, and then proteins obviously in vaccines and other sectors. We're very early, but we would love for people to help us along the path and along the journey. So with that, I will thank you for your time.